Okay, bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, wassalatu wassalamu ala rasulillah. Okay, all right, so we'll start our class today, inshallah. So as your friends have mentioned, so this is our second last class. Okay, so our last class will be on Monday, inshallah, because I just realized that on 3rd August, which is on not 3rd, the 29th July will be your Idul Adha break. All right, so we won't have class on that day, inshallah. So we'll finish at on Monday, inshallah. All right, for the last class. All right, and then you'll start your exam period on 3rd August, right? Okay, and our own exam is on 8th of August, inshallah. All right, so it will be 24 hours exam. So the the paper is ready. Okay, so we have 4 big questions. So the first questions will be on this is not in sequential. So you will have one question on PLC, one question on pneumatics, or the combination of both PLC and pneumatics. So I think we'll give you some video, and then you need to video of some applications. So and then you need to propose a solution to that, how to automate that process, something like that. So PLC, pneumatics, and then CNC, right? CNC, and then the last one is on, inshallah, on our topic that we'll learn today on layout. All right, layout. So there should be one more on SCADA, but looks like we won't put it in the final exam, because SCADA, it is more theoretical, so it's not very proper to do an open book question on SCADA. So I decided that maybe for the SCADA, I'll just give the the video and the slides, and then I'll give you as one of the questions in your quiz. Right, so your quiz on Friday, I think I'll give you more ample time for that quiz. So it's like it's a take-home quiz, but it's like quiz come assignment. All right, so it's like quiz plus assignment, but of course the marks will only be taken as the quiz, as a quiz. All right, so maybe we'll take this quiz because it's bigger than the previous ones. So this one maybe take more weight compared to the previous one. All right, so inshallah, for the quiz, I told you in the last class that we'll be having 4 quizzes. So I think I'll just give you 3 quizzes. All right, so you already have 2 quizzes. So this Friday will be your last one, but I think I'll give you, from Friday to maybe to Tuesday or something, right? Friday to Tuesday, Friday, Saturday, Sunday, Monday. So like 5 days to complete the task. All right. So that quiz will cover from CNC, layout, and also SCADA. Right. So this one also, of course, open book, and so this one you are allowed to discuss among yourself, inshallah. Right. But discuss, not copy. Okay. All right. So okay. All right. So let's start with our class today, inshallah. Is there anyone? All right. Blah blah blah. Okay. Right. So inshallah we'll go to the last topic. sort of last topic for our class. So as I told you, we also have SCADA, but I think SCADA is I just give you a video from YouTube and slide afterwards, because it's, you know, it's a more theoretical. You can just read it yourself, right? So as you can see here, process layout is actually you have prior slides before that actually. So if I may show you here, so you know, after CNC, normally we'll go to the material transport, material storage, you have the identification. All right. So you have like 3 topics. So I think for this semester, I think we skip these 3 topics. All right. But of course, I will also put these materials on the iTa'lim. All right. Just for your extra knowledge. So if you want to have a glimpse of the contents, you can go. But of course, we will not be covering those on in your examination. All right. Okay. So that's all. Okay. So inshallah, today is layout strategies and safety. Right. More on layout planning, how to plan a layout. All right. Okay. So let's start. Okay. Facility layout. Okay, as the name suggests, you know, layout is a location or arrangement of everything within and around buildings. All right, pay attention to following to decide layout design, customer satisfaction, level of investment, utilization of space, equipment and people, ease of maintenance, you know, and you want more flexibility. Okay, efficient flow material, and employee safety. All right. So of course, this facility layout is a quite a big topic, but in this course, inshallah, we'll cover some of the topics. All right, which is the basic of the layout. You know, just to give you some exposure on this layout planning. All right. So basically, you have 2 types of, I mean, 4 types of layout. All right. So first one is product, and then you have the process layout, and then you have the group technology. Okay, and fixed position. All right. So normally we'll only be covering this more coverage on these 2 layouts. Okay. So fixed position is normally is a large bulky project, so it will be at a fixed location. All right, so you don't need such a big planning as for the layout, because it is the location is fixed and people need to go at that station, and you bring all your machines there, right? So as the product layout, you know, product layout involve locating the machines and equipment so that each product follows a pre-arranged route through a series of process. All right. So this one, if you can imagine, it is more of the production line. All right. Production line. So a conveyor system. All right. Conveyor system, and this is more sequential. Right. Sequential. So for one product, you have multiple things to do, from the raw material up to the assembly. All right, and also inspection. So this is the product layout. One product and in series. I don't know, sequential, right? And then second type is the process layout. All right, so in process layout, similar manufacturing process are located together, right? So this one is more on maybe you can call it a room arrangement or a department. All right, department. So instead of a sequential like product, so maybe the first one is the, you know, the cutting, and then you go to the milling, and then you know, you have some other some other line of process. But for the process layout, you have different departments, and then you put the same similar machines together. So for example, department of CNC, so you put all your CNC machines on that department only. All right. And then you also have different process in other department, right? You group it together. So maybe assembly as a one department. All right. And then of course you need to arrange this department such that it can give you the highest throughput, okay, and efficiency. So for example, maybe you want to put your CNC department close to your, let's say, the design department. All right. So after you design using 3D CAD, and then of course using your your PLC, right? You have designed the circuit, and then you have designed the 3D CAD, and then you have designed also the electrical circuit, all right, electrical drawings. And then after the design department, this one should directly go to the CNC, for example, and then maybe for the technician that will do the wiring, okay. That's the difference between these two layouts. So normally for big manufacturing plants, they will have this type of layout together, right? So a product layout in a location, and process layout in the different location, okay. All right, so this is the product layout. So you have the station 1, station 2 in sequential. Process layout, you group together similar process or similar machines in the same department, right? Of course, you need to make sure that this process will give you, advantage in terms of your efficiency, as well as your maybe ease of movement. This one, we want to, target the highest efficiency, and also we want to lower the cost of material handling. All right, material handling, which is the cost of moving the material. All right, this is also the very costly, right? So for example, if you have lathe and drill normally very near to each other, there's maybe you put drill very far, so you need to move the material to take away a long journey. So this one will also incur some costs, all right, which we call it material handling costs. All right. Okay, so this one is the layout. So this one is the advantages. So you can go by yourself, right? So product layout, reduce material handling. So this is one of the main importance of product layout. As for the process layout, is will incur more material handling costs for the process layout. Okay, so product layout types, you have the assembly lines, or maybe you have the fabrication lines, right? So these two types, okay. And then this is the process layout that we have already discussed, right? Similar process located in close proximity. Okay, so you can see the advantage and the limitation here. Of course, the process layout, you have higher degree of flexibility, right? So instead of focusing on only one product, you can have multiple, you can play around with the design, all right? But the thing is, the material handling is more expensive, okay? So we'll discuss this in more detail after this, inshallah. So comparison, so this one you go by yourself, inshallah. You can read. Okay. lots of comparison, difference between those. Okay, so we go to the first one, which is to design the product layout. Okay, so keep in mind you have two types of layout. So product layout and process layout. So for the product layouts, we design the layout, or we plan the layout based on the line balancing. Okay, what is the line balancing? Right, line balancing is the process of assigning tasks to workstations in such a way that the workstations have approximately equal time requirements. All right, so in a sequential type of layout, you don't want to have a station that have that consume more time compared to other sessions. All right, so the ideal layout is to have the approximately same task time for each workstation. All right, so you want to distribute equally, you can say something like that, right? So you don't want to have a one session to be the bottleneck, we call it. All right, you don't want to have this type of things. Okay, so instead of you have bottlenecks, you should distribute this bottleneck to other stations, right? So that you can distribute the tasks equally to all workstations, right? That's the line balancing. You want to balance the time of the workstation. All right, so before that, we need to go through to some terms that you need to keep in mind, right? So the first one is your cycle time, which is very important. Okay, cycle time is the maximum time allowed at each workstation to complete its set of tasks on a unit. Okay, cycle time, right? So for each workstation, you have the maximum time allowable maximum time. So this is what we call cycle time. So each workstation cannot have more than the cycle time. Okay, you cannot spend more than cycle time. Okay, maximum cycle time is given by the summation of the task times. Okay, minimum cycle time is given by the longest of the task time, right? So this one we'll discuss more detail after this, inshallah. Right, so first we have cycle time, and then the second one we have the second term, which is the output rate. All right, output rate. Output rate is equal to operating time divided by cycle time. All right, operating time per day. All right, so this one is a very important keyword. Operating time per day per or divided by cycle time. Okay, so right, so how to get the cycle time? Cycle time is equal to operating time per day divided by the desired output rate. All right, so or demand, you can call it demand. All right, so what is the demand of your manufacturing process? Okay, how many demand, and then you can divide those with the operating time, right? So operating time that you have, and you divide by demand, you get the cycle time. Okay, and then the output rate you can get by dividing the operating time divided by cycle time. Okay, so don't worry about this formula. You can always refer afterwards. Don't have to memorize. Okay, so these are the steps that you need to plan or to design the product layout. Okay, the first one is you will be given the stations, and you will be given the task time for each station, right? From those, you need to develop the precedence diagram. All right, so this one I just give you the overview first on the steps. You need to develop the precedence diagram. showing the sequence and performance times for each task. And then for the second one, you need to calculate the cycle time using the this formula, right, that we have looked before, right, to meet the output requirement. Take the demand per day and divide it into the production time available per day, right? Same with the previous slide. Right. Step 3, determine the theoretical minimum number of workstations, right? So all these stations, small stations, you need to balance it into the workstations, okay? So before that, you need to determine the theoretical minimum number of workstations first, all right? How to calculate that? You use this formula, all right, which is equal to the the summation of the task time divided by cycle time. All right, so cycle time you already get from the previous step, okay? Right, so this one you just need to add on all the task time and then divide it by the cycle time. All right, and then the last part is to perform the this one is not last part. The next step is the perform the line balance, right, by assigning specific assembly tasks to each workstation. Okay, and efficient balance is one that will complete the required assembly, follow the specified sequence, and keep the idle time at each workstation to a minimum. All right, so this is a very important part. Okay, so you want to always keep the idle time at each workstation to a minimum. You don't want to have a workstation, to have leisure time. All right, you don't want them to have time which they spend without doing any work. All right, so this is a very important criteria of a efficient product layout. Okay, so if you have friends in manufacturing, right, so this is one of the most important thing that they will discuss every day, right? So they will inspect if there is a station which have a very big idle time, then they will balance with some other process or give new projects and so on. All right, so always we want to keep the idle time at each workstation to a minimum. All right, and then of course after that you need to calculate the efficiency of your design. Okay, just to want to know the performance. All right, to do this line balancing, you can follow several heuristics. All right, so you can use rule of longest operating task time. So this one I just give you an overview. When seeing the example, you can see the more clearer picture of this. Right, so longest operating task time, which is you choose the available task with the longest task time. Right, so you have also the greatest number of following tasks, positional weight. Right, you can also use the heuristic of shortest operating task time and the least number of following tasks. Okay, you have basically 5 of heuristic that you can use to do the line balancing. Okay, what are those? We'll see after this, inshallah. Okay, so let's say we have this simple precedence diagram. So normally you won't be given this precedence diagram from the start. You need to construct by yourself, right? So you'll be given some sort of table, and then you need to construct this type of precedence diagram. Okay, so let's say you are given this precedence diagram. Okay, so you have 5 stations, A, B, C, D, and E. All right, and you can see that at each station you have the task time. Okay, so for example, for A you have 0.1 minute, B you have the 1 minute, C 0.7, D 0.5, and E 0.2 minute. Okay, All right, and then you can also see that precedence diagram contain the sequence. All right, so for example, from A, the sequence is to go to B. Right, so from B, it doesn't go to C directly, it will go to D. All right, so this is the sequence of the process, okay, in this problem. Right, so from C directly go to D, all right, and D go to E. Okay, so this is the precedence diagram. So I need to allow your friends to be in this class first. Okay, all right, so this is the precedence diagram. So this is the first step, okay, to have this precedence diagram. So so this one you need to make sure that this one is correct. All right, because if you don't have this one correct, this will, you know, of course, will affect the calculation in the next steps. Okay, all right, so this is the precedence diagram in the first step. All right, so and then the second thing, you need to calculate the minimum number of workstations required. Okay, this one, of course, the theoretical is not necessarily same with the practical one, right? So you will see after this, inshallah. So this is the theoretical minimum number of workstations, okay, which denoted by n. All right, minimum number of workstation n equals to the summation of the task time divided by CT, which is the cycle time. Okay, what is the minimum number of workstation for the previous precedence diagram? Okay, can you calculate? So you just sum of all the task time. Okay, so this one, you add those, sorry, you add 0.1 plus 1 plus 0.7 plus 0.5 plus 0.2, then you will get 2.5. Okay, 2.5 here, right? And then the cycle time here, how to get the cycle time, right? So cycle time, either it is given, or you can take the longest task time. All right, so like this. Okay, I think we'll already have this criteria here. All right, so you can either take the longest task time, okay, or you will be given the cycle time. Okay, so in this case, we'll have the longest task time of 1 minute. Okay, 1 minute. So that's denotes our cycle time. Okay, so okay, still remember what is cycle time, huh? So the definition of cycle time is the maximum time required for each workstation, right? So that's why we take the you know, the one with the highest task time, we take as the CT, as the cycle time, right? So divided those, we get 2.5. Okay, and then of course, because this one is the number of workstation, it cannot be 0.5, right? So so you round it to the next number, which is 3. Okay, so let's say you calculate the theoretical minimum number of workstation, and then you get something like 2.1. All right, so what number you want to take as your number? Either you take 2, or you take which one? Can someone tell me? Which one you want to take?
3.
3, yeah? Why? Why don't you take 2? Because this one round, 2.1 round, you get 2, right? The closest integer. Okay. Right. So because you want to make sure that you can accommodate more stations, so you take this bigger number. All right. Although you will get something like 2.1, 2.2. Okay. So you go for the next bigger integer. So let's say you get 2.7, right? Also you go for 3, right? Okay, so we already have your minimum number of workstations, which is 3, right? Next, what do we need to do? And then we arrange tasks shown in previous figure into 3 workstations because we have the theoretical number of workstation 3, right? So use a cycle time of 1 minute. We already choose 1 minute, okay? And assign tasks in, using the principle of most number of followers. This one we just, choose. So in the if you calculate, you can choose any of the 5 heuristics that we seen before. Okay, so let's say we choose this heuristic, most number of followers. Okay, right. So there is another rule called the order of greatest positional weight. So this one we'll see in the next example, inshallah. Okay, so let's say we choose these heuristics. Okay, most number of followers. Okay, so let's see again the precedence diagram. Okay, if we want to rank them, rank the stations based on the most number of followers, how do we rank? Which is the one with the highest number of followers? Can you tell me? Number of followers, right? So number of followers meaning that you have the more stations that follows afterwards. All right. Okay. So if you can see here, A, how many followers? You see in this root. Okay. You can see that it has followers of B, D, and E. So it has 3 followers, right? So I think this is the biggest number, right? So we rank A as the first one, right? So the next one, what is the second most followers? The second that have more followers?
B and C.
B and C, right? So B and C, right? Because both have 2 followers, and then of course you have D and then E. So this is our rank based on the heuristics that we choose before, which is the most number of followers. All right. So keep in mind of this rank. Okay. A, B, C, D, E. Easy to remember. Okay. So based on that, we construct this line balancing table. All right. So let's say because we have 3 workstations before, so let's say we start with the workstation number 1. Okay, workstation number 1 here. Okay, we start with the cycle time, which is the maximum number of task time, right? We have determined before, which is 1, right? So because we rank them as this one, A, B, C, D, and E, right? So we start with A, right? We start with A here, and then we deduct the task time of A, which is 0.1, right? And then we have the time remaining here is 0.9, right? How to get 0.9? 1 minus 0.1. Okay, then we get the 0.9, and then you look at the next one, B and C. You can choose both, all right? But you can see that B has 1 task time, right? Of course, you only have 0.9 now, so you cannot minus 1, right? It's not enough. So you choose the next best candidate, which is C. All right, so you see C has the task time of 0.7. So 0.9 minus 0.7, you get 0.2. So you have 0.2 remaining. And then you see next, if you can go more, if you can accommodate more in this workstation, right? So you see B, of course, cannot, and then D 0.5, of course, is not enough to deduct from 0.2, right? So if not enough, then there's none, and then you take the final number as your idle time. So this is the idle time for the first workstation, 0.2. Okay. And then you get the idle time of the first workstation. You go for the next one, workstation number 2. Of course, you have already used A and C. This one cannot be used again. All right. So of course, you take the next one, which is B. B is, you see the task time is 1. Okay. And then you minus from 1 the cycle time, and you have the remaining of 0. Of course, you cannot accommodate more. So the idle time is 0. Okay. And then you go to the next one, workstation, which is 3. All right, 3. Then you can accommodate D. All right, so 1 minus 0.5 here, you get 0.5. And then you go to the next one, which is E, 0.2. And then 0.5 minus 0.2, you get 0.3. Okay. Do you have any more? No? All right. So, and then you put the final number to the idle column, right? So this is your idle time for each workstation. Okay. And then you total them up to get your total idle time, which is in this case 0.5. Okay. 0.2 plus 0 plus 0.3 equals to 0.5. Okay. So this is the idle time, meaning that you have 0.2 minute for the first workstation that you have the free time, right? Without any task, right? Similar to the third workstation, you have 0.3 minutes that the session is free, okay, without any task. All right, so next one, you already calculate the total idle time. Okay, so next you can calculate the percent idle time. Okay, so you see that how to calculate idle time per cycle, right? So this one is the total idle time, if I'm not mistaken, right? Total idle time. So this one equal to total. Okay. And then you divide it by the number of workstation and times the cycle time. Okay. And then of course you get the multiply by 100% to get the percent of idle time. All right. So, and then you, to get the efficiency, you just minus those with the 100. Okay. So this one, you put it here and minus with 100. Okay. So you just plug in the values, right? So you have the total idle time was 0.5 divided by the number of workstation, which is 3. And this one is cycle time. Multiply by 100, you get this as your percent idle time. And then you calculate the efficiency, you just minus those with 100. And this is your efficiency of line balancing, okay, which is 83.3%, right? So this one, of course, depend on your boss, what efficiency that he wants. Okay, so if he needs at least 90%, so you need to recalculate this one and maybe use another heuristics, okay, to adjust the efficiency. Okay, so this some of the heuristics that we'll see before. So we have used the most following tasks, right, for the previous example. So this is easy. You just count the number of tasks that follow, okay, for each workstation, and then you rank them up. Right. You also have this heuristic, which we call the order of greatest positional weight. Okay, how to get that? You just calculate the positional weight. No, it's the sum of each task time and the time of all the following tasks. Okay, right? This one, and then we rank based on the which one has the highest positional weight. Okay, we see in this example, maybe we use the positional weight methods. Okay, so a manager wants to assign workstations in such a manner. All right, so before that, in the previous one, okay, so this is our okay, so this is our solution, right? So we have the workstation 1, 2, 3 here. All right, so the first workstation is A and C. So this one, you balance them up like this. Okay, and B is one whole big workstation, and D and E as the one station. Okay, so by doing this, you can have a more efficiency. Okay, so these two you can say, okay, you balance your task accordingly, right? But this one, of course, in the same workstation, this one one big station, and this one is the another session. Okay, so this one is workstation number 1, workstation number 2, this one is workstation number 3. Okay, so go to the next example. All right, manager wants to assign workstations in such a manner that hourly output is 4 units. Okay, before this we didn't see this one, right? So this one is another angle, right? So we have the hourly output is 4 units. What is this? This is the demand, right? Output rate. Okay, the output, the demand. Okay, so working time is 56 minutes per hour. Okay, 56 minutes per hour, meaning that you can rest only for 4 minutes. Okay, this is working time. What is the cycle time? So this cycle time easy, operating time divided by output rate. Okay, or the demand. So you got the cycle time here. If you are not given this one, you can use the method of previous example. You take the highest, the task time, the highest task time, okay, from the from the stations. Okay, so if you are given this demand and the working operating time, you need to calculate based on this method. Okay, this one 14 minutes, so our cycle time now is 14 minutes. Okay, let's say we have this type of precedence diagram now. Okay, precedence diagram, A, B, C. So now you have more, okay, more numbers. Okay, so this one is your task time. Okay, I think this one is 3 minutes, 2 minutes, and so on. Right. So how to calculate the positional weight? You just add the task time for the session and the following session as well. So for example, for A you calculate this way. So 3 plus 2 plus 4 plus 9 plus 5. Okay, so this is the positional weight of A. All right, how about B? Same, right? B plus C plus H plus I. How about D? So D plus E plus HI and so on. Okay, so you can see the example here. All right, so if then you will get the positional weight for each station. Okay, for each station. Right, so based on this, then you rank them up. Okay, so for example, for this one, you have the which is the first rank?
F.
F, right? So F is our first rank, and then next one is D, which is 25, and then you have G. Okay, G. So, and then next, B, right? B. Next, C or E, right? C or E. Okay, and then next, you have A, A23. So A is the next to G, right? So this one A, right? Any more? This one E. Okay.
H, sir, H.
Oh, H. All right. That's why I think we have another one. All right. So H. Okay. So this is the rank of based on the heuristics of positional weight. Okay. F, D, G, A, B, C, E, H. All right. Instead of if you use the most following tasks heuristics, so you will rank something like A first, right? So A have the 4 followers, and then F also have 4, and then you will rank, maybe B afterwards and D, right? So you can see the rank is different. Okay, so now instead of those, we use the positional weights. Okay. Okay, so keep in mind the rank here. This one I've already shown the rank. Okay, so assign the task above the workstation in the order of greatest position weight. We already have this one. Okay, find out the number of workstations. Okay, how to get, still remember? This one is also the, always the theoretical number of workstations. Okay, so sum of tasks, you just sum all of this. Not sum all of this. 3, 7, 4, that. Okay, you get 45, and then we divide by the cycle time that you have calculated at the beginning. All right, so now you get 3.2. Okay, and then you round that one to the bigger, the next biggest integer, which is 4. Now your theoretical minimum number of workstation is 4. All right. Okay, so and then you arrange like in previous example. Okay, in the previous example, you have 4 workstations. So of course, based on this rank, okay, you start with F, and then task time 14 minus 5. Okay, so your CT is 14. Okay, so remaining 9, and then you take the next one, D, 7, and remaining 2. So this one is your idle time. Okay, idle time. So, and then next you put G, A, B. Okay, this is your idle time. And then next CE. Okay, and then you get this one, and next one is H. Okay, this one. So this one is your you have 0 idle time, right? 0 idle time. So you calculate those, you get 2, 5 plus 6 is 11. So you get this total number of idle time is 11 divided by the workstation and cycle time. Okay, you get the percent idle time. Okay, so percent idle time, and then you can calculate the efficiency, right? Easy, 100 minus this. Okay. All right. So that's the essence of our task. Okay. So remember, this heuristics actually is just what you call it? Just heuristics. Heuristic is the rule of thumb, right? Heuristics just as a reference for our so that we can calculate the performance of our line balance. You don't need to exactly follow this, okay? Because it's just heuristics. So for example, maybe you want to, you can see that this one is accommodate more idle time, 6, very big. So maybe you want to reduce that. Maybe I don't know, maybe you put H first. You can play around. This one is not like a very strict rule that you need to follow. This one just for your reference, just a heuristics, so that as a reference to calculate the performance of your line balancing. Okay, so maybe instead of A, you put B first, for example, and so on. Okay, of course, if you play around with that one, you will get different idle time and of course different efficiency. Okay, all right, so already 9:55, huh? All right, so this is your homework. You have time, right? So a shop wants an hourly output of 30. So if you see this hourly output, you know, okay, this one is the demand. Okay, and then the working time is 60 minutes per hour. Okay, so of course this one you need to work all the time. Okay, so what is the cycle time? Cycle time, you just know 60 divided by 33.5, right? Okay, do it by yourself. So you use this rule. Okay, I have already, so we just go this one very quickly, inshallah. Okay, so this one is your cycle time, 1.8. Okay, 1.8, and then you are given this precedence diagram. Now it looks quite different, huh? Quite different. So A, B. So from B you go to C, D, E. Okay, and then of course you have another branch there. Okay. Okay, so use positional weight. Still remember? So for A here, you just add all of this. So where do you want to add? This root, or this root? How to get the positional weight? Okay, so if you have this one as a case, all right, so you just take all of them, because A go to all of this root. So 1.4 plus 0.5 plus this plus 0.5 plus 1 and plus this. All right, so you will get something like 6. Okay, and then you calculate for B and C and all of them. Okay, and then you rank them. Okay, rank them. So in this case, you have the A as the first one, E as the next one, the fourth one is D, followed by C, G, F, and H. Okay, so that's your rank. Okay, so the same as before, right? So you have the what is your cycle time? 1.8. Okay, so based on 1.8 as your cycle time, so for each workstation, you start with this one, and because you rank A is the first one, you start with A. 1.8 minus 1.4, you get 0.4. Okay, so this one is your, because you cannot add the next one, so this one is your idle time. The second workstation, you go for the next one, B. Of course, the task time is 0.5. 1.8 minus 0.5, you get 1.3. Okay, and then 1.3, you can add E, 0.8, and then this one is your idle time. Same as for the next one. For 3, you have 0 idle time. So for your calculation, you always target for the minimum. You want to minimize the idle time. Okay, so the lower the idle time, the higher your performance. Okay, and then for the fourth one, you have the idle time of 0.3. Okay, so you total them up to get the total idle time. Okay, Okay, you calculate by yourself. Okay, calculate by yourself. 1.1, so you get 1.4, I think. Yeah. Okay. Okay, and then you can get the performance like you calculate before. Okay, very easy. This is what I told just now. So you have the bottleneck session. This one that we want to avoid. Okay, so do you want to distribute this one to other the workload of this one you need to distribute to other stations. Okay, theoretically the line should be able to produce at 60 unit per hour, but the station has test time of 2 minutes, double, therefore limiting the output to 30 units per hour. So that's why we need to avoid this bottleneck things. Okay, so next one you have this type of time balancing. So I think this one you can go through because this one is similar to what we have discussed before. All right, so like before, you are given the precedence diagram, but in applications you will be given this. Okay, so you will given the the station here A to K, and then what is the preceding task? Okay, like this one. So A, you don't have the preceding. So B, your preceding is A. Okay, so of course you should draw as A to B like this. Okay, and C followed by A and B. Okay, A and B. So C, A and B. Okay, like this, and so on. So this one is like this. Okay, like this. Yeah, like this. Sorry, like this. Okay. All right. So, what else? Next one. What do you need to calculate? Cycle time, right? Cycle time, easy. So time, you just get all the time available, which is 435 divided by the demand. You get this in minutes, and then you convert to seconds like this. Okay. Why do you need to convert? I think because you are given in term of seconds in the time. Yeah, here. So this one is seconds, in seconds. Otherwise, if this one is you are given in minute, you don't have to change, right? Because it will cancel each other. So because this one is in seconds, you convert this one into seconds. All right. So you need to be careful of that one. Okay. So minute to seconds, and then you calculate the theoretical minimum number of workstations, which is 4. All right, and then you can use any heuristics that you want to use. The first one is greatest number of following tasks, or you want to use the longest operating time, right? So if you use the longest operating time, which one go first? Right, so you rank D first, right? Longest operating time. So D, and then followed by A, followed by E, F, G, H, and then B, K, or C and K. Sorry, this one I, of course, with the H, and then followed by C, and last one is J. Right? So you can have multiple heuristics here. Okay. So then you can get like we did before. Okay, you can see here that this one is your idle time. Okay, idle time. All right, this. So you can see that although we have the theoretical minimum number of workstation is 4, but now you have in practical you have 5, right? Because in some cases you cannot accommodate this one. All right, so it's okay. You just go for what you calculate. Okay, 5. But of course, if it is 5, then this one you need to use the one that is that from your calculation, okay, from your true table. Yeah, okay, 5 instead of the theoretical ones. Okay, so you can see that using this heuristic you get 74.7. Using these heuristics you can get a very high efficiency. Okay, so this one of course will be a very advantageous compared to this. The gap is very big. Okay, so maybe I will ask something like use any heuristics that you want to use, but maybe go for minimum efficiency of 85, for example, right? So of course first you try this. Oh, no, I just got 75 74.7, and then maybe you try positional weight, okay, and then you see the efficiency again, or maybe this one still not not exceed 85. So then you use the longest operating time rule, you can get the efficiency that you want. Okay, so I think that's the wrap up of the product layout, design of the product layout. So inshallah on Monday we'll see on the process layout, inshallah, which the end of our course, inshallah. Okay, so and inshallah in today I will give you today or tomorrow I will give you the YouTube link to the SCADA. So this one you can go through, and then of course I will also upload the materials on the iTalim as well. So, and of course you can just Google the SCADA things, and then this one will be asked in your quiz. Okay, so quiz CNC, product layout, as well as the SCADA, right? So I'll give you ample time, maybe up to Tuesday, okay, to submit. So as I mentioned, you only have 3 quizzes in this semester, okay, but the third one will give you more weight compared to other. Okay, inshallah. So do you have any questions? Because I think one question before we end. Based on what disorder? All right, so this one based on the heuristics. Okay, so I told you that we have at least 5 heuristics. So the positional weight, most following number, the longest task time, right? So the shortest task time. So you need to go through that one as well. So how do we know that we have 4 workstation, and how do we divide how many tasks for each station? All right, so you go one by one. So let's say you have theoretical minimum of 4 station, then you start with the first workstation. Okay, and then for the first workstation you go to the rank, right? Which one is the first in your rank? So let's say the first rank is the station F, right? And then you just minus with the cycle time. All right, cycle time, and then if you have the remaining time, you see the next in the rank, right? And then you minus the again, and so on until you cannot add more, based on the cycle time, and then you take that as your idle time, right? And so on. Okay, so how do we divide how many tasks for each station? This one based on the cycle time, right? Remember, so for each workstation cannot exceed the cycle time. Okay, cycle time is your main reference for each workstation. Okay, is this diagram given or we make it? You may be given or you have to make it. All right, like the example that we have already shown. Okay, all right, so I think that's all for this class. You can always ask me again from my personal WhatsApp, inshallah. Okay, for that, let's end this class with tasbih kafarah. Subhanakallahumma wa bihamdika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Thank you everyone. Assalamualaikum warahmatullahi wabarakatuh.